Good morning, Akshita. Today we are starting a new chapter, that is number system. So in this number system, Akshita, from your childhood, or let's say 6th, 7th classes and 8th classes, in 8th class you might have learned about natural numbers. You might have learned about whole numbers. You might have learned about integers and their operations. Now the next set of numbers which are very interesting, that is rational numbers. So we are starting this number system chapter from the rational numbers topic. Okay, I am moving ahead. So first of all, please put the heading as rational numbers. The definition of rational numbers. Yeah, write down a number that can be expressed as P by Q form, where Q not equal to 0 is called a rational number. If you take a number, you should be able to write it in the P by Q, means numerator by denominator form, and the denominator should not be 0. So then that kind of number you can call it as rational number. And one more thing, P comma Q should be integers. Without them integers, there is no meaning. Like for example, I'll give the examples later, but fine, P and Q should be of integers and Q should not be equal to 0. This is the proper definition of rational numbers. Please write down. Yeah. Now let's see this. So only what is the goal, Akshita? We should write that number as P by Q form. Let's take an example. Half. I'm just talking in English. How do we write half as in mathematics? 1 by 2. Is it in the format of P by Q? Yes, P and Q are integers, therefore this is a rational number. One important point I wanted to say here, rational numbers are represented by letter Q. I think so it is correct. Okay, yeah. Rational numbers are represented by letter Q. Therefore, what we can say is half belongs to Q. Okay, you might be getting confused. What is this symbol? This symbol is called belongs to. What is the meaning, na? Akshita belongs to India. So this is how you can write that English statement using the mathematical symbol. This is a Greek letter epsilon, Greek alphabet. Actually, why we are using Greek alphabets and everything, na? Because many of the mathematicians are from the Greek countries, where they used their own letters for the symbols, and we are also continuing the same, respecting them. They're great people. Okay, clear. Next example, I want to give many more. See the example 3 by 4, 5. Can I call 5 as a rational number? Yes, I can call 5 as a rational number because I can write 5 as 5 by 1. Can I call 0 as a rational number? Yes, I can call 0 as a rational number because I can write 0 by 1. I can also write 0 by 2. I can write 0 by anything, any number. But still, I am able to write it as p by q form. Na? That's why 0 is called a rational number. Next, minus 7 divided by 2, negative numbers. Yeah, accepted. P and q are integers. Na? So, minus 7 integer. 2 is also integer. So integer by integer, yeah, fine, accepted. So minus 7 by 2 belongs to rational numbers. Clear? So now here one important note point is going to come. That note point is, see the first point, all integers are rational numbers. This is something and highly important point. You take any integer. Okay, let me once check it. Actually, the recording is happening properly. Yeah. You take any integer, Akshita. Just say, for example, some 99 is an integer, correct? So it is also a rational number because 99 by 1, you can edit as 99 by 1. Like that, any integer you take, you can edit by 1. Therefore, it is acceptable, p by q form, right? Next, the second point, all fractions are rational numbers. Only goal is you should be able to write it p by q form. That's it. If you are able to, that is called rational number. If you are not able to, what that is called, I'll say later. All fractions are also rational numbers. Next, third point, all decimals cannot be called as rational numbers. Only those decimals, decimals which can be written in the form of decimals which can be written in the form of p by q, they are only called they are only rational numbers. Now you might have some doubt in your brain, sir, are there any decimals which cannot be written in p by q form? Yes, plenty of them are there which cannot be written in that form. You will see them. I am going to show them. That's why this chapter is very important for you. It's very interesting also. I am going ahead. Next example, how we can call some of the decimals as rational numbers. Let's take 0.3, Akshita. How can you write 0.3 in a p by q form? Very easy. You can write it as 3 by 10. You are able to write it in p by q form, na? Therefore 0.3 belongs to rational numbers. Clear? Let's take some other example. 0.7, another example, 0.25, 0.125. Yes, 0.7 you can write as 7 by 10. 0.25 you can write as 25 by 100. 0.125 you can write as 125 by 1000. Everything you are able to write in the form of p by q. Therefore, all these numbers belongs to rational numbers. Okay. Now actually this is little high level, but I am giving you, there are some decimals which cannot be written in p by q form. You know what are the decimals is, like I cannot show you on screen, but if at all I can show you using calculator. Yeah, let's take up calculator. Here if you see square root, no, write 2 and then put square root. So this is nothing but square root of 2. Akshita, if you see 1.4142135623, this is never ending. Do you think, actually if you see here, you might be feeling like, sir, the number is ending at 7. No, number is not ending at 7. If the place permits, the whole number, you know, it will fill the whole calculator, everywhere. How much? So big, actually, so big that it will never end. You know, the universe may end actually, but the square root will never end. This kind of decimal numbers are called irrational, not rational. Irrational numbers, that we will discuss later. This is little high level for you, but now you are to that level, Akshita, where there is no discussion of low level only I should teach. No, Akshita is now fully mature about the subject, and yeah, we will go ahead. Irrational numbers, after the rational numbers chapter we will discuss this, very important. Sir, there are some decimals which you cannot write it p by q from whatever you do. No. So this is one such example, like the root 3. Also another example I'll show you. Clear? Write 3, put square root c. This is also same, but with the 4 it's not the case. Answer is 2. Correct na? So let's type 5. With 5 it is the same case. Again, it's never ending. Universe may end, but the number of the digits, they will never end. Okay. So this is what the point. So just if you want, in your notebook you please write down. If a number cannot be written, in p by q form, then it is called irrational number. Clear na? Fine. I'm going ahead, Akshita. Please put the heading in your notebook as equivalent irrational numbers. Hey, why irrational? I'm sorry. Equivalent rational numbers. We are in the chapter rational. I don't know why I'm bringing irrational. Equivalent rational numbers. Example I'll give you. Like, you know, let's say there is one rational number a by b, there is another rational number p by q. After simplification and everything, if you get that a by b equal to p by q, then rational number a by b and rational number p by q are called equivalent rational numbers. Simple and clear, right? Now the next point, I want to just give some examples to you. Let's take 2 by 3, 4 by 6, 6 by 9, 8 by 12. Let's take all this 4 by 6 after simplification, 2 2s, 2 3s, 2 by 3. Next 6 by 9 after simplification, 3 2s are, 3 3s are, again 2 by 3. 8 by 12, 4 2s are, 4 3s are, so again 2 by 3. Therefore 2 by 3 is equivalent to 4 by 6, that is equivalent to 6 by 9, that is equivalent to 8 by 12. These are called equivalent rational numbers. It's very simple to understand. Only thing is, after simplification of the fraction, you should get back to the same old original rational number. If you can get that, that means those 2 or those 3 or those 4 or whatever might be, they are all called equivalent rational numbers. Okay, fine, Akshita, we will stop our class over here. Thank you very much.